that we'll practice. Then this was the first part. Just wait. Just wait a minute. Just wait a minute. This is lagging. Let me just restart it, okay? Just wait. Yeah, Simrah. So this was the first part that we were discussing, that you need to know how to write the dimensional formula. If you know the formula, main formula, you should be able to construct the dimensional formula. Now, as I've told you, once you will be doing the chapters, formula will slowly be remembered by you and you will be able to write this on your own at the end of the session also. Then this is the first part. Second part was the derivation of a formula. Means you had to check, is the formula correct or not? Sometimes it will be given like the whole formula will be given to you. This would be given to you. F is equal to K mv square by R. Check the consistency of this formula. It means the same thing. You have to show these steps only what we have studied. Derivation of a formula. You write down the powers. You see the proportionality. You just equate the powers on the left hand side with the right hand side. That's it. This is the second part of the chapter, which you should know. Third part was conversion of one system of units into second system of units. These things we did. This one, n1 u1 is equal to n2 u2. This is the third part. So basically we have completed this chapter, but few good questions are left which we need to convert. This you solved by yourself and you got the answer correct also. 10 joules is 10 to the power 8 ergs. So this is how we solve. There's this question. See, this says that, I'll do it. We'll just have a discussion. This says convert power of 60 joules per minute. Now, this is not saying find the value of 1 joule into erg or 1 seconds or 1 minutes into seconds or something. It is saying 60 joules per minute, means in 1 minute. 60 joules per minute into a system. Now, it is constructing its own system. We know, for us right now, we know in the SI system, what have we studied? That for mass, the SI unit is 1 kg. And if you want to convert it into gram, you multiply it with 10 to the power minus 3, means 1 kg is equal to 1000 gram. For us, what is length? SI unit is in meters. If you want to convert it into the CGS unit, 1 meter, you know, it is equal to 100 centimeter. It is saying, no, don't consider your system. It is saying, consider a new system. In that new system, mass is 100 grams given. Length is 10 millimeters. And time is in minutes. Means first system we know. Let me write the first system because it is given in joules. So we know this thing. So we know first mass will be 1 kg. This is what we already know. Length and time. This mass will be 1 meter. This time will be 1 second. But the second one, usually it says, no, convert it into its CGS unit. Something like this. Usually it says like this only, where you write down this in grams and centimeter. It is saying don't take that. Don't take your CGS unit or something. That new system is told to us that your M2 will be 100 grams. Your L2 will be 10 millimeters. Your T2 will be how much? 1 minute. In minute means in a minute. It is actually in a minute. Is a minute okay? It's fine. Is a minute we are able to understand. Is a minute means it's just 1 minutes. Okay. So this is what we have as our system. Now it is saying power, you have to convert it into this system. First of all, solving this joules per minute. Did we discuss the unit, if you remember? For the, what's the SI unit for time?
Seconds.
Seconds. Now this row, this is our SI system. This is our new system. Previously, till here, this was our CGS system. We used to convert SI into CGS till before this. Right now, this question is
Okay.
saying this is our new system. So it has given us SI system and it is asking us to calculate this in new system. So in SI system, we have 60 joules per minute and it is saying find out this X, whatever it is. This is the question. You've got the question? Clear?
Converting 60 joule upon minute is equal to X, meaning into the new
Into the new system. Yes,
unit.
yes. Like we write na
Mm.
N1, U1. So this will be N1, U1, N2, and that U2 will be the new system of units.
Mm.
Okay. Like we write this formula, we write this as N1 U1 is equal to N2 U2. See, let me just explain once again, then you see if you are able to understand this or not. It is saying usually before this, like till here, this was our question, or 1 joule into erg. It used to give
Yes, ma'am.
us SI unit system and it used to ask us in the CGS unit system. So advantage was
Mm.
that we knew all these things in CGS also. SI we already knew. We used to know this in CGS also. Like when mass was given, we could easily convert it into 1 gram because we know in CGS
Mm.
unit it is 1 gram. Meter is in centimeters. Seconds remain in seconds. So we could solve this question. This question is saying this time that don't convert this into a CGS unit, convert it into some new system where instead of just taking 1 gram, you have to take 100 grams. Where you were
Mm.
taking 1 meter, 1 centimeter in CGS, you take it as 10 millimeters. Take instead of 1 second, take as 1 minute. We'll solve the question with the same method we were doing, but we will replace our
Mm.
M2, L2, and T2 with these. Now you got the question?
Mm. Yes, ma'am. We are using the new system provided by the question.
Yes, we are using this new system provided by the question. If it didn't give us this system, it would have easily asked us convert power of 60 joules per minute into CGS. Then we would
Mm.
have simply used here 1 gram, 1 centimeter, 1 seconds. This we already know. SI is
Mm.
given because this is an SI. Now,
Yes, ma'am.
before we proceed with the same method, there is one small thing that we need to perform. If you look closely, the SI system is also not completely SI. Minute is present, right? So it means this has not given us pure SI unit. So let us at least convert power into SI unit, right? It is given 60 joules per minute. Let us convert it into SI unit. Then only we'll be able to use SI. This is not any
Mm.
system. 60 joules per minute is nothing. This is not in CGS, not in SI, not in this new system, nothing. So what we do, we convert power is 60 joules per minute means 60 joules in how many seconds? 60 seconds. That is 1
Mm.
joule per second. Now, this is something that we can use, 1 joules per second. Now we can apply
Okay.
this M1, L1 and T1 also, correct? So what's the question saying? Now for
Yes,
us,
ma'am.
what will be N1, Simra?
1 as we
1.
calculated.
Exactly, this will be 1. And U1 will be?
Joules per second. We can't use what over here?
Yeah, we can use what?
Watt.
We can use what, but
We can.
with the help of what, how will we write the dimensions?
Mm.
We can use what? What is the SI unit of power? But we need
Mm.
to break down these units, so from how we will write. Like at least joules per second is giving me an idea that joules dimensions will be that of energy and this is of time.
Mm.
That's why we are breaking power. Like one more example I'll give you, pressures. Pressures SI unit is pascals. But if you get a question in dimensions, try to avoid pascals. Try to write Newton per meter as the unit. It will give you meter square. It
Mm.
will give you an idea that,
Mm.
yeah, the dimensions are force divided by area, like this. In dimensions, we try to avoid these bigger units. If we have the simpler version, we'll use it. Usually, everything has a simpler version in the dimension questions that you will get, like power, joules per second, right?
Mm.
This
Yes, ma'am.
N2 is not known to us, and U2 is given. What is this U2? The new system of units. New
Mm.
system of units which is provided by the question. Is it clear till here?
Yes, ma'am.
Okay. Now let's solve this question the way we have been solving. For N1, I will write this as 1. Now it is joules per second. So we need to write the dimensions also, no? What will be the dimension? What are the dimensions of power? Do you remember?
Uh, no, I'll have to check.
ml square t to the power minus 3. Okay, just check it. The dimensions of power is this. This is basically energy divided by time. That is t to the power minus 2. So one more t to the power minus 3. Okay, this you can check while writing. Okay.
Yes, ma'am.
So what we'll do, our first system is m1, l1 square, t1 to the power minus 3. n2 is missing, m2, l2 square, t2 to the power minus 3. This is how we were performing the previous question only. It's just that now m2, l2, t2 we won't take by ourselves. We will do what the question says. Now we have to calculate n2. The value of n2 is missing and that has to be calculated. So look, this will be m1 by m2, power is 1. L1 by L2 whole square, T1 by T2 to the power minus 3. Now let's put the values
3.
of this, right, which we have to put. So this will be 1 kg by 100 grams. Otherwise, if this was not given, we could write this as 1 kg by 1 gram. But right now we'll write it as 1 kg by 100 grams. This is 1 meter and it's given 10 millimeters whole square. T1 is seconds and this is given as 1 minute to the power minus 3. Now, if you remember, if you have revised the previous concepts, after this, what did we do?
We convert the SI units into the CGS or the
Yeah,
common one
correct. So that they can be
into the
cancelled.
denominator.
Yes, so we'll do the same here. It's just that the values will be different because 100 is there, so it will be something larger or smaller. Let me write this. Let me write kg as 1000 gram by 100 gram. 1 millimeter is 1000 millimeters by 10. I hope you know 1 milli when we write. This is 10 to the power minus 3 meter. So 1 meter is 1 by 1000 of millimeter. Okay.
Yes, ma'am.
So that's only what has been written. Milli means 10 to the power minus 3. And this is millimeter whole square is present. And 1 seconds, we can convert this as 60 seconds. Writing seconds is difficult to the power minus 3. Now let's cancel on things. 0, 0, 0, 0. Gram, gram gone. 1, 0 with this. Millimeter, millimeter gone. Second, seconds gone. Right? Now we just have to simplify it. Let's see what is left. Tell me, Simrah, from here, what is left now?
10 is left.
Yes. From here,
100.
only
No,
100
100
is left?
square.
Yes.
100 square.
100 square, 10 to the power 4. I'm just writing so that it eases the calculation. And see, this
Yes,
is
ma'am.
1 by 60. Power is negative. So what should we do?
60 raised to 3. 60 cube.
Yes, 60 cube, because it will make our calculations also easier. So see, this will be 6 whole cube is 216. So 3 into 10 to the power 5.
Yes, ma'am.
This is power. This is having the power 5. So see the value of N2. It is 2.16 into 10 to the power 5. So 10. This is the answer. If the new systems was not given, if this new system was not given, we would have got a different value. Power would have been something else. We know it's how much is 1 joule, how much is 1 second. So that is different.
Yes, ma'am.
You get this if a different system is given because these questions are there. If you have a new system, follow the instructions first. First, as it is, follow the instructions by the question. whatever questions is.
Mhm.
And then once you reach this step, means this step, then you go by the same method as we have solved, right?
Mhm. Yes,
Just
ma'am.
pay attention that when whichever system you are using, it should be uniform. Like here in the question, I could have used power also. I could have used 60 also, but I couldn't
Mhm.
because it was given joules per minute, and it's not the SI system. When I'm saying I'm converting SI into new, so I should have this also in SI, which is 1 joules
Mhm.
per seconds. Okay, so just keep this small.
Yes,
So
ma'am.
this is an important question, and it's a little tough also. Write it, you will be able to understand. These questions come in the exam because these are only present in your dimensional formula. Simra, are you preparing for
Mhm.
any exam also, JEE or NEET?
I haven't started yet, but I'm planning to write NEET, so I have to start.
Okay, all right, please write it, just text me done then. Okay.
Okay, ma'am. Done, ma'am.
Look, Simra, the next kind of tricky questions that come. See, the straight, simple questions, how we have to solve that we have done and we have practiced a lot. So in today's class, I just want to take these different questions that come. And since, as you
Yes,
told me,
ma'am.
you have to prepare for your NEET also. In the NEET also, these are the maximum tough questions that can come from dimensions. Even these kinds of questions which we are discussing right now, they also don't even come now. The questions are very simple. If you see the paper of NEET previous year, it is exactly what we are studying for this chapter specifically. I'm telling you, dimensions is exactly the same.
Mm.
And there was a question, if you remember, we discussed P plus A by V square, B minus,
Yes, ma'am.
remember Van der Waals, this equation we discussed. This
Ma'am.
question came
Yes, ma'am.
exactly in the JEE mains paper, which is currently happening on 2nd April shift 2. So
Mm.
this question came in the JEE mains paper. So see, in NEET, these questions are very much what we are discussing. So have a good practice on these, and for your uh, 11th class also, 11th class exam also, you should have the toughest preparation done so that the rest of the questions
Mm.
appear to you easy. So one kind of question
Mm.
that I've seen come is like this: if fundamental unit of force is 100 Newton, now it has changed the value of 1 Newton. We say that this dimensional formula m l t to the power minus 2 of force, this is for force, we often used to substitute it for 1 Newton,
Yes,
right?
ma'am.
This is what we
Yes,
studied
ma'am.
till now. This is what we've been using. It is saying no, don't take this as 1 Newton, take this as 100 Newton. This is the change. Got it?
Mm.
So tell me, for velocity, what is the dimensional formula?
Velocity L M1 M0 L1 t raised to minus 1.
Yes. L t to the power minus 1.
T
The
to the power
first
minus 1.
table that we have discussed, now practice that very well. That is the very basic table. And if you
Mm.
remember that properly, the questions will be very easy for you to do.
Yes, ma'am.
In your NEET and JEE exams, what is the difference? Mainly if you're targeting NEET exam, you just have to increase the speed. Questions level is the levels of the questions are not much very different. They are not much different. We have the classes going on just before you. I just had the class of NEET crash course only today because NEET is about to come. So
Mm.
there also you just have to focus on the speed. So what I'm trying to tell you is that if you have a plan, for even if you do not have a plan or you have a plan, but if in the back of your mind, if you have a plan to prepare for any entrance, just go by the class notes and the NCRT of 11th properly. Your major portion
Okay,
will
ma'am.
be done itself only. Okay.
Mm.
This is saying velocity is 10 meter per second. So which we used to write as 1 meter per second. Now it is 10 meter per second. And it is saying
Mm.
time is 10 seconds. So for time, we can simply write this time as t only, which is 10 seconds. Now we
Mm.
have to find out, it is saying calculate fundamental units of length, mass, and time. Now you have to calculate in terms of this. Now find out the length. Now find out mass. Now find out time. If this is something very,
Individually.
did you get it?
Individually, like for
Individually,
four.
exactly. Yes,
Mm.
individually. So
Mm.
time is very easy to calculate from here. If you look, this is saying directly from here, you can predict that t is directly given as 10 seconds from this.
Mm.
So time is already known. Time is,
Mm.
but
10.
see, we'll go reverse. If you know t, at least velocity can be solved now. Look, t to the power
Mm.
minus 1. So just take it as the normal equation. One variable is L is our variable. We have
Mm.
this, the way we do substitution method of maths. We take one value, then put it there like this. Now, if
Mm.
t is 10 seconds, t to the power minus 1 will be 10 to the power minus 1. Right?
Mm.
So let's put it here. L, now t to the power minus 1. I'll put it as 10 to the power minus 1. Right?
Hmm.
This
Yes,
is
ma'am.
equal to 10 meter per second. This is an easier question. Or this you will not find it
Hmm.
difficult. This is 10 meter per second. So now let us just find out the value of L. So this will be L by 10 is 10. So L will
In
be
a step,
100.
100. Hmm.
So we have got the value of length also. Now the last one, mass, is left. So we have length, we
Hmm.
have time. It's not difficult for us to calculate now. Basics units are present. So for mass, let us write M.
Hmm.
Now, instead of L, it's better if I write 100 meter, means 100, correct?
Hmm. Yes, ma'am.
So
Substituting the value of L.
yes, substituting the value of all. Now it is t to the power minus 2 in force. So I'll write 10 to the power minus 2 because
Hmm.
time is 10 seconds. This is given as how much?
100 Newton.
100 Newton.
Newton.
So this is 100. This 100, this 100 will be cancelled. Mass
Hmm.
will be, this is m by 100. So it will be 100. Right? 100.
Hmm. No.
Yeah,
Ah,
look,
yes, ma'am.
m by
Hmm.
100 is 1. Na? So m will be
Hmm.
100.
Yes, ma'am.
So this is the new system's fundamental unit. Means instead of 1 kg, you're getting 100 kg. Instead of 1 meters, you're getting
Hmm.
100 meters. And instead of 1 second, you're getting 10 seconds.
Yes.
Write this, Simrah. Let me just, I think one more question I have to discuss with you. You write this first. Okay?
Yes, ma'am.
Okay, Simrah, done? Completed?
Yes, ma'am.
Okay, one question I'm giving you, this you try first because this is not something different, but this has repeated itself in many of the school exams. This once came a long time back in Ames paper, and this this has repeated itself. So this is based on the same principle of homogeneity only, which we have studied.
Hmm.
Try this first and tell me the answer, whatever you get. Just a
Okay,
second.
ma'am.
Just a second. Okay, try it once, Simra.
Yes, ma'am. Ma'am, is it LT raised to the power minus 1?
L t to the power
Minus 1.
-1. See, this will be no.
No.
What's your A
No.
coming?
A is L. B is T. No. Wait, I forgot to calculate with force. 1 second, ma'am.
It is A by B.
Hmm. Yes, ma'am.
Okay, take a minute more, then we'll discuss.
Okay, ma'am.
Okay, let's discuss this. See, this is based on the same thing, dimensions should be same. It is saying the
Hmm.
equation is f is a root x plus bt square. Now, I'll give you the same example which I gave you in the starting. See, Simra, if you have, I asked you once, can I add 7 kg to 2 centimeters? You told me we cannot add it.
No.
But when I asked you 7 kg plus 2 kg, you told me they could be added. Remember, we had
Yes,
this
ma'am.
discussion.
Hmm.
So, if I am able to add two things of the same quantity, means they have the same dimensions, right? If 7
Yes,
kg
ma'am.
is getting added to 2 kg, you are able to add it because both of them have the same dimension. That is the dimension m, dimension of mass, right? Now
Yes,
look,
ma'am.
if you see the resultant, when we add 7 kg plus 2 kg, we never get 7 kg square, or means we never get 9 kg square. We don't get 2 times 9 into kg, nothing. We don't even get when if I subtract this 7 kg minus 2 kg, I'll get 5 kg. This kg doesn't get cancelled, so it doesn't give
Yes,
me
ma'am.
0. So what happens? If you realize here, if you notice here, when you add when you are adding two quantities of the same dimensions, their resultant also has the same dimension. The resultant also has the same dimension as that of the individual quantities. Means whatever things are present besides the plus sign or the minus sign is equal to the same dimensions of this resultant. Remember, are you able to recall this, Simra?
Yes, ma'am. Yes, ma'am.
Now, look, if this question is saying f is equal to a root x plus bt square, means, see, this is the resultant, this is the resultant. This
Hmm.
is one value which you are adding, the first one. And this is the second value which you are adding. So forget right now, these are complex terms. Look at like these boxes. It is like this
Yes,
only. Instead of the first box, we have a root x. Instead of second box, we have bt square. Instead of third one, we have the force, right?
yes, ma'am.
So it means they all the three of them have the same dimensions. Dimension of force will be equal to dimensions of a root, not 2, a root x. A root x, which is equal to dimension of bt squared. This is what is called principle of homogeneity. Means you are able to add like things together, you're able to subtract like things together. Multiplication and division can work with anything. We have seen the in the formula also. You are multiplying mass with velocity and you're getting momentum like this. You're dividing force with area, you're
Ma'am.
getting pressure. So multiplication and division work. But you must have never seen two unlike quantities getting added together or unlike quantities getting subtracted. Like whenever you get
Yes,
confused,
ma'am.
think it like, can you literally add 10 kg plus 5 seconds? 10 kg and 5
No,
seconds
ma'am.
won't be 15 something. they they
Hmm.
they cannot be added. Physically also, if you think, time cannot be added to mass. Physically also it's not possible, and mathematically also it's not possible. So what we do here, we know the dimensions of force. It will always give you one quantity whose dimensions will always be clear to you, like force. So see, dimensions, let's see the first thing, dimensions of force. What is the dimension of force?
MLT raised to minus 2.
Minus 2. Yes, mass into acceleration. So this is equal
Hmm.
to the dimensions of a. We don't know, it's a constant, we have to calculate that. Root x. Now what are the dimensions of x? Hmm?
It is L because the question stated that X is the distance.
Yes, so x will be
L.
L. So it is saying root x. Root x means this is
L
root.
raised to minus 1.
No, we never
No?
write. No, that's
Uh,
why, okay,
no.
that's why your answer must have been wrong. When you
Hmm.
have root, since when do you write minus? See, you write minus when something is in the denominator. Like if it was
Hmm.
something k by x, this can be written as kx to the power minus 1. You have just answered before this. When the time was
Yes,
1
ma'am.
by 60 to the power minus 3, you only told me that it will be 60 plus to the power plus 3. In case of
Hmm.
that, only sign changes. Something to the power root is, what's the power of x? Half. Okay?
Half. Oh, ha. Yes, ma'am.
Yes. So
I
see,
forgot that. I forgot that.
yes, so this is root L, but we don't write root, so we will write this as L to the power half. So this
Hmm.
is L to the power half. Now you can get the value. A will be mlt to the power minus 2 divided by L to the power half. So A will be m. 1 minus half is half. So L to the power half, t to the power minus 2. This is just A. Now we'll do the same thing. We know bt square is equal to this also. You can directly write this also. Bt square is
Yes.
equal to force also, because now this is revealed. A root x we know. So it's better directly
Hmm.
let's write force, right?
Yes, ma'am.
Dimension. You can use A means this dimension multiplied to L to the power half. That is A root x. And then you can equate it with bt square also. That is also fine because all three are equal. So, but
Yes,
we
ma'am.
know force it's better is equal to dimensions of, what's it given? bt square or b by t? Bt square.
BT square.
So see, force is mlt to the power minus 2. B we don't know, this is t square. B will be mlt to the power minus 2 by t square. So B will be m L to the power. Now this will become t to the power minus 4.
Hmm.
Now we have to take the ratio of A and B. This is what the question is asking.
Yes,
M
ma'am.
L to the power half t to the power minus 2 divided by M L t to the power minus 4. Mass gets cancelled. L to
Hmm.
the power 1 again half t to the power 2. Yes.
Hmm. Yes, ma'am.
Yeah.
Yes, ma'am.
Please write this. Make the corrections wherever you've gone wrong.
Yes, ma'am. Yes, ma'am. Done, ma'am.
The entire one.
Yes, ma'am.
Okay. Simra, just the last part means we are almost over. These are the only kinds of questions that come in the exam. Basic questions, revise it. What I'll do today is from this whole chapter, instead of giving you one topic's homework, I'll just give you an assignment of this chapter. Okay, that will help you
Yes,
practice. Also, you have the test tomorrow. Are you appearing for it?
I think my parents rescheduled it on 12th of April
Saturday.
on Saturday.
Saturday.
Hmm.
Okay, okay. So yes, you have this week, revise it. Questions will be simple, what we have discussed. So as an assignment, I'll give you the whole chapter. This chapter 1, important questions that can come. You practice, you share it. And then if required, if you think wherever you get stuck, anyways, we'll have the discussion of it. Okay.
Yes, yes, ma'am.
Uh, your previous homework was fine, I think. I had reciprocated it to you. There wasn't any error in that.
Hmm.
Let me just check it again. Your homework was based on this only, no? Dimensions. Yeah, Boltzmann constant. This was fine. In this second homework which you have submitted, there was this question. This is important. Let me show you also. You remember there was a question with this. N is equal to minus g, x2 minus x1, n2
Yes, ma'am.
minus n1.
The last question.
Yes, the last question. N2 minus n1 divided by x2 minus x1. That is very important. Just wherever you have it in your notes, mark that as important. And
Okay,
one
ma'am.
more thing, Simra, sometimes the questions as we have done the questions where we have to derive the formula. So in the
Hmm.
derivation of the formula, two kinds of questions means the question is the same, method is the same. It's just that two ways the questions can be asked. One is that it will ask you to check the consistency of the equation. Check the consistency of equation. When I say consistency of equation, like it will give you some equation. Check whether f
Hmm.
is equal to mv square by r or not, like this. So
Hmm.
you have to do the same thing. You will see, you will just put the dimensions of this side, solve it like LHS.
We have to equate LHS to RHS.
Yes, LHS to RHS means not exactly the derivation one, dimensional
Hmm.
formula one. And then at the end, you have to prove that yes, LHS is equal to RHS, hence prove this is consistent. If you see, suppose I give you MV square by R square, then you will not get it equal because this is not the formula. So you say this
Hmm.
is not equal, equation is
Hmm.
inconsistent.
Okay, ma'am.
If I give you the equations like this, half mv2 square minus half mv1 square is equal to kinetic energy. So in this case, don't subtract these two. Apply your principle of homogeneity only. You're not subtracting, you're not using maths here. This
Yes, ma'am.
dimension will be equal to this dimension, which will be equal to this dimension only. So you can just use dimension of kinetic energy. The dimensions of kinetic energy will be equal to any one of it. So don't
Hmm.
subtract it or write it double. Just write it as mv square and check whether it's equal or not. You know for energy,
Okay, ma'am.
you know for half mv
Yes, ma'am.
square, then prove for LHS is equal to RHS or
Hmm.
not. Just check. What I'm saying in
Okay.
these questions can be tricky. What we do, we write the dimensions of these minus the dimensions of these. These will be just cancelled. You don't need to write, you don't have to solve them. You will have plenty
Hmm.
of time the whole year to solve these questions. Okay. And
Yes,
there
ma'am.
is one more type the question can be asked is if velocity, pressure, speed of light, no, not velocity, acceleration due to gravity. Acceleration due to gravity, pressure, and speed of light. Suppose this is just an example I'm taking. Acceleration due to gravity. This is basically acceleration only. This
Yes,
is
ma'am.
pressure. This is the speed. So, speed, pressure, and acceleration are the fundamental units.
Hmm.
Then find dimensions of length. Like this, a random question will be asked. See, this is just a change in the language. This is the same thing which we have discussed. You will write L
Yes,
is
ma'am.
directly proportional to G P C to the power X Y Z and get the equation. Okay?
Yes, ma'am. The derivation one.
Yes, that
We have to
derivation.
use the derivation way.
Yes,
Hmm.
yes. So that can be asked. Now, once you have the derivation done, let's say we are getting something right now. I have just taken random thing. Let's say you are getting G square C by P after get deriving the formula. It
Yes,
said
ma'am.
dimensions. So then just put the dimensions. You have the formula now. The
Hmm.
new random formula is there with you. You have calculated, you have derived it, you have got it. Now put their dimensions and see what is the new dimension of length. Clear?
Hmm. Yes, ma'am.
So these are the maximum things that can be asked in this chapter. Apart from it, no question is left that can be asked. Okay, so just write down it as note point. Just make these as note points that you remember how you have to solve in the exam. Okay.
Okay,
I'll
ma'am.
start with differentiation in the next class now. Differentiation. Calculus part we'll do.
Mm.
Just write it, text me, then I'll end the class. So this completes with the first chapter.